We cannot recreate Earth, the planet, with current technology. Earth's mass is about 5.97 times 10 to the 24th kilograms. Its atmosphere near the surface is roughly 78% nitrogen, 21% oxygen. Its water inventory is about 1.386 billion kilometers cubed, and its magnetosphere helps shield life from harmful solar and cosmic radiation. Those are not small engineering details. They are planet-scale conditions. The scale mismatch is overwhelming. World crude steel production in 2025 was 1.8494 billion tons. If you absurdly devoted all of that to building Earth by mass, you would still need about 3.2 trillion years to equal one Earth mass. Using Falcon Heavy's published payload of nearly 64 metric tons to orbit, lifting just one Earth atmosphere would take about 80.25 trillion launches, and lifting the mass of all Earth's water would take about 2.17 times 10 to the 16th launches. So, a literal second Earth is not merely hard, it is outside present industrial civilization by many orders of magnitude.
So, if you force me to do it using only current technology and current resources, the only serious interpretation is this: we recreate Earth's functions, not Earth's full planetary mass. That means building a self-sustaining Earth analog world: breathable air, closed-loop water, agriculture, soils, forests, wetlands, microbes, animals, industry, weather control, waste cycling, and long-term habitability for a large human population. That is still colossal, but it is at least within the envelope of known physics and known engineering. We already have pieces of it. The ISS has demonstrated 98% water recovery. Biosphere 2 operates as a controlled multi-biome testbed. Indoor farming is real enough that FAO issued a global review in 2025. Solar PV is already a material part of the power system, and the world has 416 operating nuclear reactors, providing 376.3 gigawatts as of November 2025, where Phase 1 happens on Earth. Not because that is glamorous, but because it is the only rational place to prototype a synthetic Earth system. You need ports, mines, grids, machine shops, hospitals, fabs, chemical plants, seed banks, universities, and a labor force. The first new Earth is a chain of closed, expanding biomes built in coastal deserts or other low biodiversity, high sunlight regions on our existing Earth. That lets us test atmosphere control, food webs, disease control, nutrient loops, and emergency response without betting civilization on one leap. Biosphere 2's value is exactly that. You learn how coupled ecosystems behave when you can't hide mistakes in the open atmosphere.
Phase 2, if the project succeeds, moves to free space. The best long-term destination is not Mars first and not a random asteroid. It is cislunar space, near Earth, near the Moon, close enough for rescue, communications, and spare parts. A NASA settlement study notes that moving material from the Moon to L5 or GEO can require far less transport energy than moving it up from Earth. One-sided analysis put the Earth to L5 energy requirement at roughly 20 times the lunar equivalent. That makes the Moon the logical quarry once you have enough robotics and processing capacity. So the answer to where is 1. On Earth first in sealed experimental biomes, 2. Then in cislunar free space in rotating habitats assembled from Earth-made starter hardware and later lunar-derived bulk material. How? 1. Define the target correctly. Do not try to build a second natural planet with plate tectonics, a molten dynamo core, a moon, and wild oceans from scratch. Current technology cannot do that. Instead, define success as a manufactured world that reproduces Earth's life support outcomes. 1G living environment, Earth-like air, closed water cycle, stable food production, radiation protection, ecological redundancy, long-lived industrial base, population growth without ecological collapse. That is not cheating. It is the only version of Recreate Earth that current technology can even begin to approach.
2. Build a seed world on Earth. Start with a stacked prototype ladder. Prototype A, 1 to 10 hectare sealed habitat. Prototype B, 1 kilometer square multi-biome habitat. Prototype C, 10 to 100 kilometer square networked habitat cluster. Prototype D, city-scale closed district with industry, food, and recycling. Each prototype includes residential volume, greenhouse agriculture, algae bioreactors, fungal waste conversion, aquaculture, wetlands for biological polishing, machine shops, medical facilities, independent power, full atmospheric monitoring, water treatment and reuse, and quarantine zones. You do not advance until the smaller system can run for years with minimal imports. 3. Use existing power systems, not imaginary ones. A recreated Earth dies without abundant energy. You need power for lighting crops, pumping water, desalination, climate control, oxygen generation, fertilizer production, recycling, metallurgy, chip making, transport, computation. With current technology, the backbone is a hybrid power stack. Solar PV for cheap daytime bulk power, nuclear fission for 24/7 baseload, batteries or thermal storage for smoothing, gas backup during the terrestrial prototype phase only. Later, in space, massive solar becomes easier because there is no weather. Solar PV already supplied 5.4% of global electricity generation in 2023, and global electricity demand grew strongly in 2024. Nuclear remains one of the few mature, firm, low-carbon sources at large scale, with 416 reactors operating worldwide in late 2025. That mix is exactly what a synthetic world needs: cheap, variable energy plus hard, reliable baseload. 4. Recreate the atmosphere as a controlled industrial product. Earth's near-surface air mix is not magic, it is a managed gas inventory. NASA summarizes it as about 78% nitrogen, 21% oxygen, and 1% other gases. In a synthetic Earth, you make and maintain that deliberately. How? From nitrogen from air separation on Earth during the terrestrial phase. From oxygen from electrolysis plus biological oxygen production. From CO2 held in a narrow band for plants and people. Argon and trace gases added as needed. Continuous leak detection and pressure control. Fire-safe oxygen partial pressure design. Atmospheric circulation fans and thermal zoning. Scrubbers for VOCs, particulates, and pathogens. This is easier in prototypes on Earth, harder in space. But it is current technology: air separation, gas storage, electrolysis, catalytic processing, and environmental monitoring. 5. Recreate the hydrologic cycle as plumbing plus ecology. Earth's water inventory is vast, but a habitat does not need an Earth-sized ocean to function. It needs a reliable, closed water cycle. The ISS has already shown 98% water recovery is achievable in a harsh engineering environment, and that's before adding a mature ecosystem. A synthetic Earth water loop looks like this: potable water loop, gray water loop, black water digestion, urine recovery, condensate recovery, atmospheric humidity capture, biological polishing in wetlands or algae systems, membrane filtration, reverse osmosis, UV and thermal sterilization, emergency mineral balancing. On Earth, initial fill water comes from municipal supply or desalination. In space, early habitats import water. Later habitats seek extraterrestrial sources. But with current technology, only sampling from asteroids has been demonstrated, not industrial mining. OSIRIS-REx returned asteroid material in 2023, which proves rendezvous and sampling, not large-scale resource extraction.
6. Recreate food systems as a designed ecology, not a wild one. Do not attempt copy every species on Earth. That fails immediately. You begin with a minimal viable biosphere, staple crops, nitrogen-fixing plants, pollinators, decomposer fungi, microbial consortia, fish and invertebrates, and small livestock only energetically justified. Engineered soils, seed banks and cryobanks, and disease surveillance from day one. The agricultural backbone is greenhouses, hydroponics, aquaponics, algae, mushrooms, controlled environment orchards, and some outdoor-style soil beds inside the habitat for resilience and psychological benefit. FAO's 2025 review confirms that indoor farming, hydroponics, aquaponics, and enclosed systems are already real and expanding, though they require strict food safety controls. That is exactly the right lesson. Your artificial Earth must be farmed like a hospital, not romanticized like a wilderness.
7. Recreate ground with engineered geology. You cannot make plate tectonics on demand, so fake what matters: bearing surfaces, soils, mineral nutrient cycles, water retention, erosion control, topographic diversity, carbon buffering, and microbial habitat. Use crushed rock, biochar, composted organic matter, ceramic aggregates, perlite or basalt fibers, microbial inoculation, synthetic drainage layers, and mineral amendments. Mountains, rivers, deltas, marshes, and forests in the recreated Earth are landscape machines. They look natural, but they are engineered for drainage, nutrient transport, biodiversity support, and maintenance access.
8. Replace Earth's magnetosphere with shielding mass. Outside Earth, one of the biggest missing planetary functions is magnetic or radiation protection. NASA notes that Earth's magnetosphere shields us from harmful solar and cosmic particle radiation. Your new world must replace that protection with material shielding. With current technology, the realistic answer is water as shielding, polyethylene or hydrogen-rich materials, regolith berms or shell mass, storm shelters for solar events, habitat layout that places tanks, soil, and storage around living areas. NASA and related studies continue to examine water-rich and polymer-rich shielding strategies because they are practical with known materials. So the habitat wall is not just a wall, it is life support, radiation protection, thermal mass, and storage all at once. 9. Use rotation for gravity. A true Earth recreation needs gravity close to Earth normal. Current technology cannot generate gravity fields, but it can create artificial gravity by rotation. That means rings, tori, or cylinders. So the mature off-world habitat is a rotating settlement, not a static dome. The living surface is on the inside of the rotating shell. Farms, towns, lakes, and forests line the interior. Sunlight enters through mirrors or light channels. Industry sits in non-rotating or low-value peripheral sections. This is not science fantasy, it is classical structural mechanics plus life support engineering. What we lack is not physics, but scale, capital, and political endurance. 10. Build industry inside the world from the beginning. A habitat that cannot repair itself is not Earth-like. So, from the first serious prototype onward, include steel fabrication, glass production, polymer manufacturing, machine tools, electronics assembly, water chemistry lab, pharmaceuticals, fertilizer production, spare parts inventory, robotic maintenance. If every broken pump requires Earth resupply forever, you have not recreated Earth. You have built a fancy terrarium. 11. Govern it like a ship, not a nation-state. Closed worlds fail socially before they fail chemically if you are careless. Governance must assume no unmetered externalities, strict maintenance culture, transparent resource accounting, emergency authority with hard limits, public health surveillance, reproductive policy planning, environmental audits, conflict resolution mechanisms, anti-monopoly rules for oxygen, food, water, and power. Earth works because its buffers are huge. Your synthetic Earth will have smaller buffers. That means bad politics becomes a life support failure.
Why? Because recreating Earth is really about preserving the conditions that make civilization and biospheres possible. The reasons are strong. Civilizational backup, expansion without waiting for terraforming miracles, climate-resilient food and water systems, extreme environment engineering, off-world survival capability, deeper understanding of Earth itself. Biosphere 2 literally markets itself as a place to study Earth's future and prepare for life beyond our planet. That is the right philosophy. The project is not an escape from Earth. It is an attempt to learn how Earth actually works by being forced to rebuild its functions from scratch. Can we do it? Yes, partially. We can build the components of a recreated Earth now. Sealed habitats, atmosphere control, water recycling, indoor farming, large-scale power systems, isolation, automation, robotic assembly, rotating structures in principle, radiation shielding with known materials. No, literally, we cannot currently build a second Earth-mass planet, a self-generated Earth-class magnetosphere, full natural plate tectonics, a self-assembling planetary oceans and climate, a complete duplicate biosphere with current ecological understanding. So, the truthful answer is, we can recreate an Earth-like world. We cannot recreate Earth, the planet.
Should we do it? Yes, but only under one condition. It must make life on current Earth better, not serve as an excuse to neglect it. A project like this should produce better recycling, better drought-proof agriculture, cleaner power, better wastewater treatment, more resilient housing, better disease control in food systems, better disaster shelters, stronger planetary stewardship. If it becomes billionaire escapism, it is morally unserious. If it becomes civilization-scale resilience engineering, it is worth doing. Must we do it? If humanity intends to survive for the very long term, yes, not because Earth is disposable, but because single-planet species are fragile by definition. But the first duty is not to abandon Earth, It is to become capable of rebuilding Earth-like conditions anywhere. That is the real task. So here is the most honest, do-it-anyway conclusion. We do not recreate Earth by trying to manufacture another 12,756 kilometers wide planet with 5.97 times 10 to the 24th kilograms of mass. That is beyond current technology by absurd margins. We recreate Earth by building a distributed, expandable Earth analog civilization, closed biomes on Earth, networked arcologies and industrial ecologies, rotating off-world habitats in cislunar space, air, water, food, and waste cycles with minimal losses, radiation-shielded, gravity-normal living environments, self-repairing industry, redundant ecological webs, expansion from one habitat to many. That is achievable only in stages over decades to centuries using technology we already know: power plants, desalination, electrolysis, recycling, greenhouses, reactors, robotics, machine tools, launch vehicles, and closed-loop life support. The obstacle is not that we lack all the tools. The obstacle is that we have never integrated them at world scale.